right, y'all. Good morning. We are going to tackle today without me. So you should by now have had some time to work on your warm-up. If for some reason you started this video early and you have not yet worked on your warm-up, go ahead and somebody pause this video for me and give you about 10 minutes to get this warm-up done, okay? All four of these should be possible, especially number 1 and 3, because we are dealing with just inverses in general. And we know the first step to inverses is to switch our x and our y. Okay, so I'm going to start with that. Okay, so for number 1, and I'm writing on one that's y'all's size, so hopefully I can fit all of my big handwriting in here. All right, so we're going to start by just switching them. X equals negative 4y minus 1 over 2y minus 4. Okay, and remember the ultimate goal here now is to resolve for y. Okay, so I'm going to go ahead and multiply up here. So 2xy minus 4x is going to equal negative 4y minus 1. Okay, and then I'm going to bring my y's together. So I'm going to pull this 4y over. Make that a plus 4y, and I'm going to pull that 4x over to the right side. Okay, so now remember the goal is to get y by itself. So at this point, I'm going to see here that I have these two y's that I'm going to factor out. Okay, and then the last step will simply be to divide by the 2x plus 4. Okay, so our y, or our y prime, or you could write that as f inverse, is going to be 4x minus 1 over 2x plus 4. Okay? All right, so in that same idea, okay, I'm going to go ahead and go down here and do number 3. We're doing the same thing here. We're switching y and x. So this is going to be x equals 1/2 y cubed plus 5. All right, so from there, now we're going to start getting y by itself. So I'm going to move the 5 first. Multiply by the 2 next. So that's going to give me 2 times x minus 5 equals y cubed. Okay, you can either go ahead and distribute that out. You don't have to, but I'm going to just to make it a little bit cleaner. So whenever I take the cube root here, it's going to be that y equals the cube root of 2x minus 10. So then to write that in inverse notation, I'm going to do f negative 1 of x equals the cube root of 2x minus 10. Okay, so those are our two inverse problems there. All right, so going over here, stating the domain. Remember, domain are our x values. So we've got a top and a bottom. The bottom, we're usually much quicker on remembering what we can and can't have. So like right here, when I look at the bottom, we automatically know that we cannot have plus or minus 3, because that's going to give us a 0 there, okay? And we can't have a 0 in the bottom. And remember, up here, we want to have a positive number. So we want 4 minus x squared to be greater than 0. So let's just think about that. We can math that out, but we know the answer is going to be some kind of 2, plus or minus 2 of some sort. So the question is, so we've got negative 3, negative 2, 2, and 3 on our sign analysis, right? And negative 3 we know, and negative 3 and positive 3 are our asymptotes. So when we think this out, like if I put 2 in here, that gives me 0. Okay, well that's cool. If I put 1 in here, that gives me the square root of 3. I can do that. If I put 5 in here, okay, then that's going to give me a negative value. Okay, so if I put 3 in here, 3 squared is 9, 4 minus 9, negative 5. That's it. Okay, so anything outside of my 2's is not going to work. So anything inside of my 2's gives me a positive number. We know that. Okay, so anything in here between -2 and 2, 0 gives me -1, 1, all of those work. That gives me a positive number, okay? So that is really my stipulation. It has to be, because if you look, your asymptotes are now outside of that domain restriction in the top. Okay, so I can go ahead and say that my domain is going to be from -2 up to 2. Or we can do interval notation -2 to 2. And that is because if I go anywhere outside, including these asymptotes, if I go anywhere outside, it's not going to work for the top. So this is my most restrictive part. Okay. All right, last one, number 4. Okay, if we know that these two lines right here are parallel, so we can mark them. Okay, then we've got a transversal. And y'all, this one should be pretty straightforward for you, because right here you see you got a straight angle. So we know that x plus 82 should equal 180, therefore x is going to equal 98. All right, so that is your warm-up. Make sure you hold on to that. Make sure you have all the work, not just the answers. And now we are going to move into today's notes. All right, so once those have been passed out, go ahead and pause the video, make sure those have been passed out if you need to. And then we're going to get right into it. Lots of exponent rules, lots of examples today, but things that you have done before. All right, so test 4, lesson 1 on, y'all are already in test 4. On our exponent laws and real exponents in general, okay? All right, so we've got the laws kind of written here on this page, and then I'm going to use some examples just for you to follow along to understand those laws. It's easy enough for me to just tell them to you and you to accept them as fact, but we need you to understand them. All my pens together. Okay. All right, so b to the x times b to the y equals b to the x plus y. I've just thought, y'all have always told, when I teach Math 1, I've always just said, hey, this is how it is, understand this. But I'm just going to give you an example of that. Like if we had x cubed times x squared. Okay, ultimately that's x times x times x times x times x. And when you look at that, that is 1, 2, 3, 4, 5, which is x to the 5th. And that is what we would have done. We would have done it. Now notice, this is the key for today's lesson, is about your base. So whenever we do our exponents, we add our exponents, our base does not change. Our base is still x. There are problems today that your base is going to be a number, okay? And you've got to detach yourself from wanting to multiply those numbers, because that number is acting as a base, okay? And we'll get through that whenever we get there, all right? Second one, whenever we divide, we subtract. Again, that's what we've always been told. So if I have x cubed over x squared, remember it's the same thing as x times x times x over x times x. And then the ones that are alike can cancel, boom, boom, leaving me with x to the first, which is the same thing as 3 minus 2. All right, number 3, b to the x equals b to the y if and only if, that's what this means, if and only if, okay, x equals y and b does not equal 0, 1, or -1. All right, in other words, y'all, if you have the same base, no matter what your exponent is, if you have the same base, you can solve that by setting your exponents equal to each other. Okay, so 2 to the third equals 2 to the x, if and only if x equals 3. Okay, it makes logical sense. You're like, well, duh, but whenever you get into a different type of problem, it will come in handy, but you will have to solve it. It's not just straightforward like that, okay? All right, number 4 here. All right, ab to the x is the same thing as a to the x, b to the x. All right, so let's do something like 2x quantity cubed. So remember, that's the same thing if we cube it as writing it 3 times. And then if we apply our rules from up here, right, there's 1, 2, 3, 2, so that's 2 cubed, and 1, 2, 3, and x cubed, which is 8x to the third. Okay, 2 times 2 is 4, 4 times 2 is 8. Notice it wasn't 2 times 3, it wasn't 6. It was 2 times 2 times 2, which gave me 8. All right, number 5. All right, very similar, just with division. So a over b to the x is a to the x over b to the x. So x over 2 cubed would be the same thing as x over 2, x over 2, x over 2. All right, which on the top gives me 1, 2, 3, x to the third, and 2 to the third, which again is x cubed over 8. I don't want to zoom too much. Okay. All right, a to the x equals b to the x if and only if a equals b and x is not 0 and a and b are greater than 0. Okay, so up here, okay, we had the same base and we were discussing the exponents being equivalent. Down here, we're going to have a different base. We're going to have a different base and the same exponent. Give me 1 second, y'all. All right, sorry, y'all. Okay, so like I was saying, now here we have the exponents are the same, but they're saying, what about our base? Well, same thing, okay? So if the exponents are the same, then for them to be equivalent, that base has to be 5. Okay? All right, number 7, bx to the y. And remember, power to a power, our general rule is just to multiply those. So let's see why that works. X squared to the third is the same thing as x squared times x squared times x squared. Back up here to where all the way back up here where we're multiplying, we add our exponents there, right? So 2 plus 2 plus 2 is 6, or the shortcut is just 2 times 3 is 6. All right, so 8 and 9, again, these are ones that we have just kind of told you are the rules and you've just kind of accepted them. So I'm just showing you why they are the rule. So like for 8, b to the 0 equals b equals 1. All right, so we've always talked about anything to the 0 power is 1. And you've really never argued with that. You've just kind of accepted it, and that's cool. But basically this is why. All right, so because for law number 1, let's let y equal 0. Okay, so that means b to the x times b to the 0 would equal b to the x plus 0, right? So law number 1, we're way up here. Understand that. That's what I'm doing. B to the x, let's let y equals 0. So b to the x times b to the 0, okay, equals b to the x plus 0, which is the same thing as just b to the x. Therefore, this right here acts, it didn't change my answer, so b to the 0 is acting like a 1. All right, so likewise down here below that, back to law number 1, okay, we're going to let y equal negative x. So b to the x times b to the negative x would equal b to the x plus negative x, which is b to the 0. And we just talked about b to the 0 is the same thing as 1. So right here, since their product is 1, b to the x and b to the negative x are reciprocals. Okay, so when I ask you about reciprocals, and you go ahead and say, oh, the reciprocal of 1/2 is 2 over 1, or the reciprocal of, 4 is 1 over 4. Okay, it's the same thing. B to the x and b to the negative x are reciprocals of one another. All right, so let's look at number 10. A couple more. Look at number 10. I'm going to have to kind of write under here as well, y'all. Okay, so because we're going to get law number 7 for this one. So we're using law number 7 right here. Okay, law number 7. We're going to let y equal 1 over x. Okay, so if we do that, then b to the x to the 1 over x equals b to the first. Okay, so if you had b squared times 1/2, the 2's are ultimately going to cancel, and it's going to give us b. All right, last one of our examples down here. So basically, number 11 is going to combine 7 and 10. So 7 and 10 is what we're putting together here. Okay, so understand this. This is the way that I've always remembered this. You can write it however you want to. Okay, but anytime you have a fractional exponent, okay, this is your root, and this is your exponent. All right, y'all. Exponents have always been high. Okay, they stay high. All right, they've always been the ones that are up top. That's where you know it's an exponent. Anytime I ask what an exponent, everybody, oh, the number's up top. Yep, So it's going to stay that way. That top number is going to stay up top, and that root is going to go in your right-hand area, okay? So like if we had b to the 4/3. So that 4 is going to stay with b, okay? And the 3 is going to come in what I call it the crack. Okay? All right, so now let's move into some actual examples of this. Okay? So here we go. Now, it is so tempting. I know, it is so tempting to just type these in the calculator and see what you get. Okay, but we're not going to do that because we've got to understand the rules, and sometimes they don't want just a single answer, or it's going to change whenever we have variables in there. All right? So we're going to start with the first one. Okay, the first thing you need to do whenever we're dealing with exponents is we need to see if we can get it to the same base. All right, so this does require you to know your multiplication facts. So when I look at this, let me move this. There we go. Okay, sorry. All right, so right now I have the lowest base I have is a base of 2. So I need to try to make 4 and 16 into a base of 2, and I can do that. All right, so I'm going to write it over here to the left just to understand. Okay, so 4 is the same thing as 2 squared. 16 is the same thing as 4 squared, right? Well, we just said 4 was the same thing as 2 squared. And power to a power means that's the same thing as 2 to the 4th. Okay, so now I have everything in a base of 2. Okay, so we're going to rewrite that. So 2 to the 8th. All right, 4 became 2 squared. And we're going to raise that to the negative 5 because that's what's there. Over 16 became 2 to the 4th raised to the negative 1. All right, so now let's just apply our exponent rules. Do not multiply the 2's. That is your base. It's like an x. Okay, so do not multiply the 2's out. The 2's have to stay the same, and our exponent rules apply from there. All right, so right here I'm going to apply this one first and this one first. So that's going to leave me 2 to the 8th times 2 to the negative 10th all over 2 to the negative 4th. Okay, now I'm going to apply law of, I'd have to go back and look. Law number 1. Okay, law number 1, we're going to add, multiply, we add our bases. Okay, so 8 plus 10 is 2 to the negative 2 over 2 to the negative 4. All right, I'm applying law number 2 now. We're dividing, so I'm going to subtract those. That's going to be 2 to the negative 2 minus, negative 4. Let me make that cleaner. Let me fix that. It's supposed to be a negative 4. Okay? And negative 2 plus 4, I'll write that 4 once my whiteout dries, y'all. Okay, so negative 2 plus 4 is going to be 2 squared. And 2 squared is 4. Okay, so again, yeah, I'm well aware we can type that into the calculator, we can hit enter, we're good. Okay, but on your worksheet today, if you don't show that work, you don't get the credit for what you did. All right, letter B. Let's see if we're dry yet. Okay, there it is. There's our pretty 4. Okay, sorry about that. All right, letter B. A lot going on here, but again, first thing I'm going to notice, okay, is this base. So 5 is my lowest one, so I'm going to try to turn everything into a base of 5. Well, we know how to do that. 25 base 5 is 5 squared, and 125 base 5 is 5 cubed. Okay, so now let's write that out. Okay, so we're going to leave the radical for now. Okay, so 5 squared cubed (5 to the n) all over 5 cubed to the 2 minus n. Okay. All right, well, let's clean that up some. So here we go. 2 times 3 right here is going to give me 5 to the 6th times 5 to the n over, distribute here, 3 times 2 is 6 minus 3n. All right, so when you multiply, you add, which moves me to 5 to the 6 plus n over 5 to the 6 minus 3n. All right, when you divide, you subtract. So that's going to give me the square root of 5 to the 6 plus n minus 6 minus 3n. All right, simplify that out. All right, so 6 minus 6 cancels here. N minus, so that's going to be a positive 3n. So that's going to give me, I'm going to go back down here, y'all. Okay, that's going to give me the square root of 5 to the 4n. Okay, and we're going to even simplify a little bit further. We don't leave that radical there. So remember, if there's no number here, it's an understood 2. So I can write this as 5 to the 4n over 2. Square root, same thing as the 1/2 power, so 5 to the 4n over 2, which ultimately gives me 5 to the 2n. Okay, it does take some time, take some work. It's a process. Okay? All right, letter C. Ooh, we got a 4, we got a 6, and a bunch of numbers inside. Okay, so let's get rid of that radical first. Let's make him go away, make it a little bit prettier. So basically the 6 is going to go here. Okay, so we're going to say 27a negative 1b squared to the 4 over 6. All right, 4 over 6, y'all, obviously reduces, so we're going to write that out as 2 over 3. And then we're going to apply rule number 4. Okay, so we're basically going to distribute this exponent into each one of these terms. Okay, so that's going to become 27 to the 2/3, a to the negative 2/3, and b to the 4/3. Okay, so all I did was, there's a 1 there, so there, and there. All right, so 27 to the 2/3. Real quick. That's the cube root of 27 squared, right? Or you could write it like this as well. Well, the cube root of 27 we know is 3, and 3 squared is going to be 9. So I know that the 27 to the 2/3 power is 9. Okay, a to the negative 2/3 is going to go to the bottom, and b to the 4/3 will stay on the top. All right, so now the only thing is we cannot have a fractional exponent in our denominator, so we do need to rationalize this out. Okay, so I'm going to write this down here again so you can see it. Okay, so I need to turn 2/3 into a whole. So if I have 2/3, I need a whole. I need to add what to 2/3 to give me a whole, and that's going to be 1/3. So we're going to multiply the top and the bottom by a to the 1/3, which is going to give me 9 a to the 1/3 b to the 4/3, sorry, all over a, because 2/3 plus 1/3 is 1. Now we don't have a fractional exponent in our denominator, so we are good to go. All right, woo-wee. Number 9 just looks horrendous to begin with, okay? I'm not even going to pretend that it's not going to be somewhat confusing as we go through it, but we're going to get through it step by step. All right, so we've got all this going on to begin with. So what I am going to do to start with is I'm going to go ahead and I'm going to break this up into 2 fractions that I can work with individually, okay? All right, so it's going to be 9 a to the 1/2 b to the negative 1/2 all over 12 ab to the negative 3/2 minus 6a squared b to the 1/2 over 12ab to the negative 3/2. Okay, so I'm just breaking it up. And we're just going to treat them individually and work down from there, okay? So left side first, 9 over 12. Okay, well, 9 over 12 we know is going to reduce down to 3 and 4. Okay, so 3, make sure y'all can see when I write, 3 and 4. Okay. All right, so we got 1/2 on top and 1 on bottom. So 1/2 minus 1. That's what we're doing here. 1/2 minus 1. It's going to give me negative 1/2. And then negative 1/2 minus negative 3/2. Let me get a sticky note here and show you this math. Okay, it's just the rules, but I'm going to show you the math. All right, so if I've got, for that one, I've got negative 1/2 minus negative 3/2, which is going to give me 2/2, which is just 1. So that's just going to give me b to the 1st. All right, 4 is on the bottom. So this one right here is simplified to this point. Okay. Only thing I do need to do is I want to get rid of that negative exponent, right? So we're going to go ahead and move him down. Okay, so then it's going to be 3b over 4a to the 1/2. All right, we'll deal with the 1/2 here in a minute. All right, so let's look at the right side now. All right, 6 over 12 is 1/2. Okay, cool deal. So minus, it's going to be 1 over 2. All right, 2 minus 1 gives me 1. And 1/2, here we are again. Positive 1/2 minus negative 3/2. So that's going to be 4 over 2, which is 2. So that's just going to be b squared. All right, well, that one's already kind of pretty. So now the only issue is our denominator. We need to make this one fraction, so we need a common denominator. Again, we can't have a fractional exponent. Okay, so to make this 1/2 turn into a whole, we're going to multiply it times a to the 1/2. Do that on top and bottom. It doesn't change the problem. Okay, so now we're going to end up with 3a to the 1/2 b over 4a minus AB squared over 2. There's nothing that told me I can't leave that there, so I'm going to stop there. You could 3-step cross multiply. The only thing about that is you're just going to end up with what looks like something that can simplify a little bit further. So I would probably take either answer here. Okay? All right, letter E. Letter E. Oh, base of 3. So again, don't type it in. I know that's tempting. Don't type it in. Okay? We're going to work through it. All right, so very similar to what we did on letter D. Now, we can try to do different things here, but I'm going to treat this just like letter D. It's just a lot simpler and with a base that's a number instead of a variable. All right, so here we go. This is going to be 3 to the negative 2 over 3 to the negative 3 plus 3 to the negative 1 over 3 to the negative 3. Well, let's apply our exponent rule so I can get my little handy-dandy sticky note. Okay, so basically that's negative 2 minus negative 3, which is 1. So this turns into 3 to the first, plus negative 1 minus negative 3, which is 2. So this turns into 3 squared. Well, look how pretty that got so fast. 3 to the first is 3, 3 squared is 9, and 3 plus 9 is 12. Okay? All right, so your next page has a completely blank page and it says solve on your own. There's absolutely nothing on that page, okay? So we're going to go through a few problems. I'm going to give you like 3 of them. Pause the video, okay? Take about, 2 minutes a problem or so, okay? I'm not going to give you too many. I don't even know how long my video is currently. But then you've got a worksheet to do before you leave class today, so I do need to give you time to get that done as well, okay? So this is what your worksheet looks like right now. Now, it's just a blank sheet of paper, so solve on your own, okay? I am not going to work here because I have line issues, so I'm going to get me some line paper. Y'all know I can't write straight as it is, so that whole blank piece of paper was giving me extreme anxiety. Okay, and like I said, we're not going to do a whole bunch of them, but we are going to try to shoot through some of these. So example number 2. All right, letter A. So here we go. Letter A is going to be 2 divided by 4 to the negative third. All right, so again, first thing we want to do is try to make these into the same base. Okay, or if you're completely simplifying, you can get away without doing that just by applying your exponent rules. You can do it either way. Okay, I'm going to do it both ways just to show you. All right, so if I wrote this out as 2 divided by 4 to the negative third, that's what that's saying, okay? Well, we know 4 is 2 squared, so 2 divided by 2 squared to the negative third. So that's 2 over 2 to the negative 6. All right, this is the same base way. So then when we subtract 1 minus negative 6, right, because there's a 1 there, 1 minus negative 6 is going to give me 2 to the 7th. All right, and this is where we're just going to use our, real quick math knowledge. 2 to the 7th. Okay, so basically we know 2 squared. So 2, 4, 6, and another 1. So 2 squared is 4. 4 times 4 is 8. 8 times 4, okay. So 4 times 4 is 16. 16 times 4 is 64, and 64 times 2 is going to give me 128. Okay, so that is one way to do it. All right, the other way would be just to apply math rules. And again, this is all without a calculator. All right, so if I just applied the different math rules here, okay, that again would be 2 over 4 to the negative 3. That's our original problem. Okay, well, negative exponents means in the wrong place, so I'm going to move it up. So 2 times 4 to the third. You could have told me 4 to the third was 64, and we would still get 128. Now, the goal of today is exponent rules, so they have like bases, which is why I prefer you to look at way number 1. But as long as you have work and we aren't just typing things into the calculator and hitting enter, we're good. All right, letter B. All right, the square root of b to the 2n over b to the negative 2n. All right, well, let's see what we got. If we just leave the square root here, so that's going to be the square root of, so we subtract here. So 2n, where's my handy dandy sticky note? So 2n minus negative 2n. Oh, that's going to give me 4n. So the square root of b to the 4n. Okay, square root is the same thing as the 1/2 power. I'm going to write it that way this time. So b to the 4n to the 1/2 power, just so you see it, which we did earlier as just b to the 4n over 2. And you get that because you can multiply those together. All right, and b to the 4n over 2 is going to turn into b to the 2n. Okay? All right. Letter C. Let's do 2r to the negative 1 to the 4th times 4r squared. Let's see. What exponent do I want to put there? Negative 2. Okay, there we go. All right. So let's just get rolling. Straight into it. Okay? So remember, this means 2 to the 4th and r to the negative 1 times 4 for that one. And this is 4 to the negative 2 and r to the 2 times negative 2 for that one. All right, 2 to the 4th, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so that's going to give me 16r to the negative 4 there. And this is 1 over 4 squared, so 1 over 16 r to the negative 4 there. Okay? Well, whenever I look at this, y'all, I'm going to see that this 16 and this 16 are going to cancel. So now I have r to the negative 4, r to the negative 4, which is r to the negative 8. Don't leave that negative there, so it's going to be 1 over r to the 8th. Right, letter D. Negative 3 into the negative 3 squared over negative 9 into the negative 4. Okay, and y'all, seriously, you can pause the video. Once class is over, this video will be uploaded into your Canvas for you. So if there's anything you missed today, you can go back and rewatch and fill in. Okay? Take a second. Try to work through it. We're going to do about, we'll do 2 more. Maybe 3. Okay? All right, so don't start by simplifying here. Can't do that because we've got that exponent there. Okay, so this is going to be negative 3 squared and then n to the negative 3 times 2. Bottom's going to stay the same for now. All right, so that negative 3 squared is going to give me 9 into the negative 6 over negative 9 into the negative 4. Oh, we got the 2 9s. Now they can cancel, but I do have the negative. All right, and then if I bring out, oh, I need a new sticky note. Okay, if I do negative 6 minus negative 4, that's going to give me negative 2. So even if my ends cancel here, my 9's cancel, sorry, then gives me the negative 1. It's going to be n to the negative 2. And again, we cannot leave that negative exponent as the answer. Negative 1 stays on the top, and that n to the negative 2 moves to the bottom. All right, let's pick another good one. Let's try this one. Okay, so you've got to resist. You cannot distribute that 2 because we've got a minus sign in the middle. So we've got to simplify in here first, and then we're going to go outside, okay? So when I say simplify in here, so 4 to the negative 1 is the same thing as 1 over 4. 2 to the negative is 1 over 2. Okay? 1/4 minus 1/2. All right, well, we can 3-step cross multiply, whatever you want to do. So that's 2 minus 4 is negative 2 over 8. That's negative 1/4. And then we're going to square that, making that 1/16. All right. That one seemed too simple. Okay, let's go with this one. Let's go with this one. 2 plus x to the negative 2 to the negative 2. Ooh, wee. All right, let's see. Well, don't start moving out until we get inside simplified, okay? So this is the same thing as 2 plus 1 over x squared. Now, you're squaring that. You can go right now and you can multiply that out twice and do your distributive property, your FOIL. Or I am going to go ahead and simplify this down by 3-step cross multiplication. So by doing that, I'm going to do 2 times x squared is going to give me 2x squared plus 1 times 1 is 1 over x squared. And then that's raised to the negative 2 power. Okay, well, if it's raised to the negative 2 power, really it's just the positive 2 power if I flip it upside down. Okay, so what I'm saying is I can flip my fraction here and put x squared on the top and 2x squared plus 1 on the bottom, and now I'm just squaring it. And now I can do that. I can square x squared and get x to the 4th, and I can square 2x squared plus 1. Ooh. And get, because we can all multiply really fast, square this, that's 4x to the 4th. Multiply it together, that's 2x squared times 2 is 4x squared, and then square 1 is 1. And here is your answer. All right, so the last one I'm going to do for you is going to be this one right here. Okay, last one I'm going to do. What number is this? Letter F. G. Okay. All right, we're going to do this one. X to the negative 1 over x minus x to the negative 1. Oh, all these negative exponents. Okay? Well, let's see what we got. This will be the same thing as 1 over x on the top over x minus 1 over x on the bottom. All right, well, the top's one fraction. We'll deal with that. Let's get this to one fraction. Okay, so if I 3-step cross multiply again, put the 1 here. So x times x is x squared minus 1 over x, and 1 over x is on the top. Y'all, when you have a denominator on the top fraction and a denominator on the bottom fraction, they cancel. Here's why, just so you understand. 1 over x times, you would flip this, and it would be x over x squared minus 1. That's why they can just cancel, okay? So we are left with 1 over x squared minus 1. That wasn't even that difficult, okay? All right, so you now have worksheet T4L1 to work on and finish during class today and get that turned in before you leave. All right, I will be here after school today. If there's anybody that needs to stay, I'll be back. Harper's appointment's at 1 something, so I will be back this afternoon if anybody does need to stay after school for anything. Okay? Alrighty, y'all, you have a wonderful day, and I will see you tomorrow.